Today I'm going to show you one of the fascinating plants that have inspired even the IITians from IIT Bombay to build a new type of structural material which can have a hydrophobic nature, and that is a taro plant. We call it arbi in Hindi, but in English we call it taro plant. And this plant is very fascinating by its hydrophobic nature. What happens when you put some water or droplets onto it? So what happens? It will try to remove everything, try to self-clean itself due to its nature and the structure that is present in the leaf. So you can see as soon as I'm putting the water, it's combining into droplets and it's not wetting the surface. This happens due to the rod-like structures which is having a waxy layer which allow us to create non-wettable surface. So this property of non-wetting or having a high contact angle results in making this leaf a super hydrophobic material. I'm going to show you how IITians have developed a nano imprinted material which is similar to this taro leaf nanostructure and having a contact angle of more than 148, 150. So these inspiration can be taken into real picture by making such devices for coating applications, or even we can make our room floor as a non-wettable material by taking the inspiration of such. So to demonstrate how actually hydrophobicity works and how we can use it and how we can present in any of the exhibition or any of the classes to students. So I'm just trying to prepare a small experiment to show how a waxy layer and a normal layer will differentiate the movement of water on the surface. So I'm using a polystyrene based pen holder, and I'm trying to create a coating of oil onto it, because we know oil is having a different behavior as compared to water. They does not mix. So I'll make a coating of oil and try to put water onto it and see how it's behaving. So the job is done. I have coated in a plastic. So on this I'm putting a few drops of water using a baby feeding bottle, because actually I don't have a syringe right now. So we need to take care that if we are performing such experiments, we always used to have a experimental setup or experimental apparatus which is having a uniformity or consistency in the results. So if I'm putting a drop of water right now onto it, so the height and the speed, how the drop is falling, everything will create a problem, not a problem, create differences in your results. So I'm trying to put, because it's just an observation. So now I'm putting water directly on my substrate which is non-coated. There is no oil, nothing. I've cleaned it. Now you can see what happens when I put water. So as you could see, the water droplet is not flowing right now. It's because it's making a contact that can be water electrostatic interaction, and because of that it's not flowing properly. But what happens when you're putting a layer of oil, it's creating a barrier between the substrate and the water, and the oil is not allowing the water to stay or to hold the surface of the substrate. So this is how an hydrophobic material works. There will be always a waxy layer or something, the nanostructure of that material. There are different possibilities that can take part simultaneously. So but when we see the RB leaf, so it's having a rod-like structure, a porcupine-like structure, which is coated with waxy layer, wax crystals actually. So that will help the water droplet to does not stay or accumulate there and directly allow them to flow off. So if we put some drops particles onto it, so we can see how these leaves can stay